Hi there, and thank you for clicking on this practice set for solving log equations. Please give this video a quick thumbs up if you find it helpful. Subscribe to the channel for more math content. Drop a comment, let me know what you think, and check out the many other videos and playlists on the channel. I'll be sure to link those at the end of the video. As always, pause the video at this point to work these problems on your own, then come back to check your work. Okay, so we're going to take these two at a time. So we have our first one here. Log base 5 of 2x minus 3 is equal to 2. And for this one, since I can't set the arguments equal because I only have the one log, I'm going to opt to change this and write it as an exponential. So the base of the logarithm would be the base of my exponential. The 2 over here becomes my exponent. And then my argument ends up by itself. 5 squared is 25. And then we'll add 3 to both sides to get 28. And 28 divided by 2 is 14. And of course, we want to do a quick check on that. 2 times 14, I don't care what it is. I mean, it's 28, but it's more than 3. What I care about is that it's more than 3. So that number minus 3 is going to be greater than 0. We're good to go. Number 2. We have log base 2 of x squared minus 2x is equal to 3. So same format on this one. They're the same like kind of style or setup to the problem. And so we'll use the same strategy. We're going to have a base of 2. The 3 becomes our exponent. And then we have x squared minus 2x. 2 to the third power is 8. And this is a quadratic, so we need to get a 0 on one side. We'll go ahead and subtract 8 to get that 0. And this is factorable. I need two numbers that multiply to -4 but add up to -2, and that would be -4 and +2. So x minus 4 is equal to 0. Add 4 to both sides, we get x is equal to 4. X plus 2 is equal to 0. And subtract 2, and we get x is equal to -2. Now, we do need to check this. And so taking a look at this, if I plug in 4, 4 squared is 16, and then 2 times 4 is 8, 16 minus 8 is positive. And then -2 squared is +4. So it's -2 times -2 is +4. And then this will be -2 times -2 again. So -2 times -2 is +4. So I have 4 plus 4, which is 8. And we're good to go. Both of those check. Okay, so both answers checked on that one. Next one, this one, number 3, is going to require that we use some properties of logs here. And so we are going to use the property that says if I am adding 2 logs together, that is the same as multiplying the arguments. So we'll have x times x plus 6. And then this now fits the form that we were just looking at, okay, where we'll have a base of 3, an exponent of 3. And what I'm going to do when I go to rewrite this is I am going to go ahead and do that distribution out. So that'll be x squared plus 6x. 3 to the third power is not 9, okay, not 9. That is 27. It's 3 times 3 times 3. And now we'll go ahead and subtract the 27. So x squared plus 6x minus 27. I need 2 numbers that multiply to give me -27, but add up to give me +6. And so that does work. These are factorable. This will be x plus 9 and x minus 3. So x plus 9 is equal to 0. Subtracting 9, I get x equals -9 as one of my solutions. X minus 3 is equal to 0. So we'll add 3 to both sides, and I get x is equal to 3. So now making sure that this checks. The -9 plus 9 is 0. isn't gonna check, but it would fail right here anyway because I can't take the log of -9. So -9 does not check. Checking the 3 plus 9 is positive, and log of 3 is positive. So the 3 checks out okay. So that one, only one of the solutions checked. Number 4. Log of x plus 9 minus log of x is equal to 1. So on this one, we will also be using a property of logs. This one will use the property that says if you are subtracting logarithms, you can rewrite that as a single logarithm, but as division of the argument. So x plus 9 over x. And we also need to remember for this one that if we do not see a base to the logarithm, that the base is 10. And so this one will invoke a different, no, we're going to be, using the same strategy here, where we're going to change the form over. So I will have 10 to the first power is equal to x plus 9 over x. Remember that this division or fraction bar is division, and I can undo that by multiplying. And so I'm going to multiply both sides by x. On the left-hand side, 10 to the first power is just 10, so that's just 10x. Here, the x's cancel out if I divide by and then multiply, or you can think of it as x over x is 1. Either one of those will work, leaving me with the x minus 9. Let's go ahead and subtract an x from both sides. That gives us 9x is equal to 9. And dividing both sides by 9, I get x is equal to 1. And we do want to check that. So 1 plus 9 is positive, and log of 1, that's fine too. So that's positive, and so our answer does check. Yay. Okay, keep going. I just recorded the lesson for this, and it was a really long video. So my stamina is worn out a little bit. Okay, so number 5, we have 2 times log base 4 of x is equal to log base 4 of 11x minus 24. And for this one, we will use the property that says if you are multiplying by a coefficient, you can take that coefficient and move it into the exponent. So this will become log base 4 of x squared equals log base 4 of 11x minus 24. And so this uses the other strategy where we would set the arguments equal to each other. So we will have x squared is equal to 11x minus 24, and we have a quadratic. So we've got to go ahead and either use the quadratic formula or factor this puppy. And I am going to set this up by subtracting 11x and adding 24 to both sides. So we have x squared minus 11x plus 24 is equal to 0. And two numbers that multiply to positive 24 but add up to negative 11 would be negative 8 and negative 3. Using the zero product property, two things multiplied together, the product is 0. Well, one of those has to be 0, so we get x minus 8 is equal to 0. Add 8 to both sides, and we get x is equal to 8. And x minus 3 equals 0, so add 3 to both sides, and we get x is equal to 3. We need to check that, and they're both positive, so the first one checks okay. What we need to make sure, and it looks like the second one checks as well, is like 11 times 8, like that's going to be 88. You can subtract a 24, that's going to be fine. And then 11 times 3 is 33. 33 minus 24 is still going to be positive. So we have both of them checking. All right, number 6, we're halfway done. Yay. Log base 2 of x minus 2 plus log base 2 of x minus 4 is equal to 3. And this is invoking, again, that property. If I have two logarithms and they are added together, I can write those as a single logarithm and multiply them. So we're going to have x minus 2 times x minus 4. This one will be a change the form. So we'll have a base of 2 raised to an exponent of 3. And I'm going to go ahead and multiply these through. So I'm basically going to do the FOIL process, or like you can use an area model, but that'll be x squared minus 6x plus 8. 2 to the third power is 8. Make sure you don't say 6 there. Subtracting 8 from both sides, I get 0 is equal to x squared minus 6x. Now this one is a quadratic, but this one does not have the c term. So usually, like, I need two numbers that multiply to 0 but add up to -6. That actually probably would work. You're going to get like -6 and 0. So it would work. Or you can just do GCF factoring and say, okay, the greatest common factor is x there. But I have seen students do this. Well, they'll do x minus 0, x minus 6, which would get you to the same spot. Totally fine. So x itself could be 0, or x minus 6 is 0, add 6 to both sides. So my two candidates there are x equals 0 and x equals 6. Checking the x equals 0, 0 minus 2 is negative, so that does not check. 6 minus 2 is positive, 6 minus 4 is positive, so the 6 does check. And again, that check, we're not used to doing, we don't do these checks like all the time for every kind of equation. So it can be easy to forget them. But think about multiple choice questions. Multiple choice questions, you would almost assuredly have like x equals 6 is an answer choice, x equals 0 is an answer choice. And you're going to have x equals 6 and x equals 0, and then I don't know, maybe x equals -6 because somebody will go back to the factor, but you're going to see the unchecked version as one of your answer choices. And so if you're not checking it, you're going to pick answer choice C when it's not. And that would be a shame, because if you got all the way to x equals 6, x equals 0, you know a ton about solving logarithmic equations and can execute a procedure really well, and then you end up missing the points because of a check. So we want to remember to check. All right, number 7. We have the natural log of x squared minus 4 is equal to the natural log of 3x. This is one where we can set the arguments equal. So we'd have x squared minus 4 equals 3x. I'm going to go ahead and subtract the 3x from both sides to get x squared minus 3x minus 4 is equal to 0. Two numbers that multiply to -4 but add up to -3, that would be a -4 and a +1. So x minus 4 is equal to 0 and x plus 1 is equal to 0. Add 4 to both sides, x is equal to 4, and subtract 1 from both sides. And again, we need to make sure we go back and check. So 4 squared minus 4 is positive. So what I'm doing is I am quickly taking the 4 and saying, okay, 4 squared minus 4 is positive, 3 times 4 is positive. -1 squared is 1, 1 minus 4 is negative, so that's not going to check. Or you can get it over here, 3 times -1 is -3, so that will not check. So this is one where only the 4 checks. All right, number 8, log base 6 of x plus 3 plus log base 6 of x minus 2 is equal to 1. Again, we have two logarithms being added together, and so we are going to multiply the arguments. So x plus 3 times x minus 2. And we will change the form over on this one. So 6 to the first power. And as I did before, to kind of save time and space, I'm going to go ahead and multiply that. So that'll be x squared plus x minus 6. 6 to the first power is just 6. And so we get 0 equals x squared plus x minus 12. And I need two numbers that multiply to give me negative 12, but add up to give me a positive 1. And that would be x plus 4, x minus 3. X plus 4 equals 0. X minus 3 equals 0. Subtract 4 from both sides to get x equals negative 4. Add 3 to both sides to get x is equal to 3. And write off really quick, negative 4 plus 3 is negative. Negative 4 minus 2 is, that's negative. That does not check. 3 plus 3 is positive. 3 minus 2 is positive. The 3 does check. Almost done. Two more problems, which, if I recall, get a lot messier. So you're probably thanking me for that. Probably not, because I've gone through these pretty fast and it's taken me 15 minutes. So it's like an ambitious problem set here. It's okay. We can do hard things. Number 9, log base 3 of x plus 1 plus log base 3 of x minus 2 is equal to 2. We've done this, I feel like, a lot at this point. So this will be log base 3 of x plus 1 x minus 2. And so changing the form over, we get 3 squared. And again, I'm going to go ahead and do that multiplication through x squared minus x minus 2. This is 9. So we are going to subtract 9 from both sides. And this is not factorable. 11 is a prime number, so its only factors are 1 and 11. And I cannot get a negative 1 from a 1 and an 11. I can get like 10 and 12 out of that. Not even, but okay. So that means we have to invoke the quadratic formula. So x is equal to the opposite of b. B is negative 1. So the opposite of negative 1 is positive 1, plus or minus the square root of b squared. Negative 1 times negative 1 is positive 1, minus 4 times 1, because a is 1, times negative 11, all over 2 times 1. This would be 1 plus 44. And so we have 1 plus or minus the square root of 45 over 2. And just like a quick little aside, the square root of 45 is equal to the square root of 9 times the square root of 5. So it's 3 root 5. Okay, so we get 1 plus or minus 3 root 5 over 2. So I have two possible solutions to this. Loving this, not really loving this, but we have to check the 1 plus 3 root 5 over 2, and we have to check the 1 minus 3 root 5 over 2. Now, because I want to make things fairly simple, we are going to just try to check this as quickly as we can. This one right here is positive, and so a positive plus 1 is positive, so don't need to worry about that. What might become problematic is the positive minus 2. I need to make sure that this is actually greater than 2, which I believe that it is. Because if it were just 1 plus 3, 1 plus 3 would be 4 over 2, which would be 2, and 2 minus 2 would be 0. But it's not 1 plus 3. It's 1 plus 3 and a little bit. So 1 plus 3 and a little bit over 2 should be a little bit more than 2, which should make that solution okay. And so we're going to quickly double check that on the calculator. So we have 1 plus 3 root 5. And then take that and divide it by 2. And yep, we are good. We are good. I got like 3.8. Oh, wait a minute. 3.8, which is fine. Okay. But when I plug that, when I plug that in for the yeah, -2 is fine. So we're good. Now sorry, that was really clunky. Okay. And now looking at this one right here. So this one, I believe, is going to end up being negative because 1 minus whatever that value is, the 3√5, it's greater than 1. And so this is going to be negative. If I take a negative and subtract 2 from it, I'm not even going to look over here. A negative -2 is more negative, and so that one does not check. Okay, and again, we're trying to do that as quickly and efficiently as we can. On something low stakes like a practice set that you are doing for homework, that's low stakes. What we just did is probably fine. If you are sitting there facing a high stakes test, I would grab a calculator and I would double check that, and I would slow this down, just because the stakes are higher and we want to make sure that we're not kind of missing something, because we all will miss stuff. All right, and last but not least, number 10. So we have log of 2x plus 1 equals log of x plus 9 minus log of x. So on the right-hand side this time, we are going to invoke the property that says if I subtract 2 logs, I can rewrite that as division. And now I can set the 2 arguments equal. So 2x plus 1 is equal to x plus 9 over x. And I'll undo that division there with a multiplication. So we'll multiply both sides by x. On the left-hand side, distributing the x, we get 2x squared plus x. On the right-hand side, the x's, if I divide by x and multiply by x, those will cancel each other out, leaving me with x plus 9. And then we'll go ahead and subtract x from both sides and subtract 9 from both sides, which I realize I didn't have to do. I did all these out yesterday. Okay, and the reason I said, I did not need to do that is, my instinct is, oh, it's a quadratic, go get that 0. But when you have a quadratic that does not have a b term, or your b value is 0, you can actually, we can move the 9 back over. 2x squared is equal to 9, divide both sides by 2. So x squared is equal to 9 halves. Now we're going to take the square root of both sides, but remember that that is a plus or minus that we got going on there. The square root of 9 is 3. And then I'm going to go ahead and do a quick rationalize the denominator there. So we have 3 root 2 over 2. Now we do need to check that. The negative version of that I can eliminate immediately. Negative 3 root 2 over 2, because right there I've got to plug in that value for x, and that's negative. So we can go ahead and just eliminate that. So it looks like we're just got to tangle with the 3 root 2 over 2. Which is positive, and I think we're going to be good. 2 times the positive plus 1 is positive. A positive plus 9 is positive, and of course we've already determined that that was positive, so we don't have to tangle too much with that. Okay, so that took me minus the introductory part, which was not very long, probably a little bit over 20 minutes. So again, like as with the lesson, kind of ambitious. Please don't forget to give this video a quick like if it was helpful, if this was a good problem set. Even though it was long, even though you might have been sitting here doing this for like an hour and you're like, if it was helpful for learning and practicing that, please give it a like. Subscribe to the channel to get more math help. Drop me a comment and let me know what you think. You should have done this in 3 lessons. This was way too much for 1 lesson. And check out the other videos on the channel, and I hope to see you in a future video.